everyone. So today I'm going to be presenting my assignment for predicting machine learning model for electrical energy output of a combined cycle power plant. My name is Rupali Nagel. The project overview is to predict the electrical energy output PE of a combined cycle power plant. The data set was provided in the CCPP file with 9,568 data values, and the variables that were identified in the spreadsheet of the data file was ambient temperature, pressure, humidity, exhaust vacuum, and electrical energy output PE. So with regards to this assignment and the presentation, I'll be covering the modeling approach, model building, model evaluation, model interpretation, and all of that. The features and targets. So the features that were identified from the data set that was given in the CCPP data file were temperature, ambient pressure, relative humidity, and exhaust vacuum. And the target PE net hourly electrical energy output. So this is the target and these are the features. And I've added the snippet of the data file. I did a little bit of data pre-processing to make sure that the data is complete and there are no anomalies or discrepancies. And I checked for missing values and outliers, so there were none, which was great. So our data is clean. And also, I had split 80% of the data for training and 20% of data for data test for the model testing. So model selection, I have used two. One is the random forest, the other one is the gradient boosting performance. So I used the Python code for both the models to calculate the MAE, MSE, and RMSE, and wanted to put those values in my presentation for the comparison to make sure that we understand which model is performing better for this case study. So we evaluated the performance of the gradient boosting regressor on the test set to assess how well the model predicts the PE based on the input features like temperature, ambient pressure, relative humidity, and exhaust vacuum. And the numbers that got generated were 3.415 for MAE, MSE was 16.225, and RMSE was 4.027. And the next model that I have used is a random forest regressor, and this is the model to test the set to evaluate how accurately the model predicts the net hourly electrical energy P. So both the models showed different values. So the MAE for this one was 3.24, and then for MSC it was 15.552, and then for RMSC it was 3.944 megawatt. And I'm going to be coming to the conclusion later, but wanted to show the comparison of the two models with regards to the three metrics that we calculated. So MAE for the gradient boosting is 3.415, and it is much lesser for the random forest or regressor, which is 3.43. Again, the gradient boosting performance for model showed the MSE close to 16.2, but it was much lesser for the random forest regressor, and RMSE also was less for the random forest regressor, which was 3.944. So the conclusion that I have drawn from both the model is that random forest model demonstrates strong performance with fairly low error metric across MAE, MSE, and RMSE compared to the gradient boosting model. The random forest model exhibit a slightly better performance with lower metrics, and based on these results, random forest is a promising model for predicting net hourly energy output and could be fine-tuned further for better prediction. So that's pretty much about it. Thank you.